Hey there, today we'll be doing this question that appeared in Codeforces around 835 day 4D challenging valleys. And the question statement is you are given an array of length n. The array is called valley if there exists exactly one subarray and the subarray consisting of A and starting from L to R, and we have to follow these conditions. And what are these conditions? Let's just check it right here. So I've already taken a sample input right here, and according to them, the conditions that are mentioned right here, we have to check that I'll be taking some subarray. Okay, some subarray. Let's just say this is my subarray right here. And what do we do for that subarray? For that subarray, we are simply just going to uh, take a value. That means we'll be taking a subarray such that these four conditions satisfy right here. So the conditions are, let's just say we are taking this subarray right here, something as 2 and 3. Let's just say if this is the summary that we are taking, according to them, what we need to take is we need to make sure that the first condition satisfies, and the first condition is saying that all the values in the subarray should be equal. Okay, this is our first condition according to them. Otherwise, it can be so that I'm standing at the, let's just say, at the first index. Okay, if I'm standing at the first index and that is what I've chosen as a subarray, let's just say I just have only one element in my array, right? So L to R can be inclusive of that same index. That means I'll be taking L is equals to R. That means I'll be taking only one element in my subarray. Fine. And the other two conditions are that you can be standing at L is equals to 0. That is perfectly fine if you're standing there. But let's just say if you're not standing at L is equals to 0, that means your starting subarray's index is not equals to 0. Then you need to take care of a situation or a condition wherein the previous element should be greater than the starting index of your subarray. That means I'll just zoom it and I'll just show it right here. Let's just say we are starting our subarray from something like 1. We are starting it from here. Fine. We can see the L is this. This is our L right here. If I'm taking 1 based indexing, it will be 1, 2, 3, 4. The starting index is 1. Fine. Sorry, 4 for our subarray, and we can see L minus 1 is greater, right? So that is what this condition is satisfying. And also we need to take care of the fact that wherever my R is, it can either be on the last index, then it is perfectly fine, or if I am choosing my R to be somewhere anywhere in between, if that is the case, the right side or the next element should be greater than where my R is. Let's just say my R is currently now this one. Fine, this is my R right now. This here is my R. And this is just for the explanation purpose, okay? Because we also need to make sure that all the elements in between these subarrays should be equal. So this is just for the explanation purpose. This is not our actual answer for this one. But here, if you are taking this R, we are rest assured that the next element will obviously be greater than me, right? So these are the two conditions that you need to take care of. So basically, what the valley is meaning is we are having something like this. That means if I'm having some element, let's just say 1 in between in my valley, the left part will be greater as well as the right part will be greater. Fine. This is what you need to take care of. But you can never have something like this, right? 3, and then at behind you have something like 1, and again at the right you are having something like 1. You can never have this. Fine, you can never have actually this, but you can actually have something like this. The value is something like this. That means since we had been said that if you're standing at L is equals to 0, right, the subarray can be exempted. That means this is a perfectly valid subarray, even though I do not have anything at the back. So I'll just ignore that fact, but you can see the right element is actually greater, right? Isn't it? The right element is greater, so that is actually satisfying one of my conditions. But there is also one thing you need to notice, that there should be only one such subarray such that all these conditions are satisfying. All these conditions that are satisfying should be only be true for a particular subarray. Okay, there cannot be more than one subarray such that all the values or all the conditions are satisfying. Fine. You just need to take care of that. Now, how to do this? So, a simple way to do this question is just try to find whatever's given here. Now, how do we do that? So, if you just carefully see, I'll just shrink in this test case for you a little, and it will be good to go. So, let's just say we have 3, 2, 2, and 1 for now. So, how many subarrays do you think there are possible in order to do this? Now, we firstly know that we'll be needing some equal number of elements, right, in my subarray. Now, those equal number of elements can be 1, 2, 3, 4, whatever you like to take. So, for now, let's just say we are taking this as my subarray. Will this be possible? Let's see. So is this forming actually a valley? So whatever the element on the left is obviously greater than this guy right here. That is satisfying one of the condition, but the R is actually lesser than this two. So this can actually not form a valid valley, okay, or a valid subarray for now. But if we, let's just say we take this, what are we having? We are having to the left we have some value obviously, and it is greater, and to the right we have nothing. So if R is at last index, we can just exempt whatever's at the right. Okay, we can just ignore the fact that is there is anything on the right. So this is actually a perfect valley, and this can be included in our answer. This is very much true. Now, does there exist any more such valleys? That is what you need to consider. So if we see, there are no more valleys that could be found here. But let's just tweak this a little bit, and let's just say this is again one. So we could see that this is one of the valleys present here. Fine. But when we are at index 0, this will again form a valley, right? Why so? Let's just see that when we are standing at L is equals to 0, and I'm saying that this is my subarray. I'll be taking this subarray only as a perfect valley that we need to make. So I'm standing here. So L is equals to R. I've said this is my subarray right here. Now, whenever we were standing at L is equals to 0, we did not have to take care anything uh, from behind, right? We did not care about the previous part. We just cared about the right part. So is the right part greater than the left one? Obviously it is. So 2 is greater than 1. So that means it is forming another valley. But in the question they have stated that you just need to have only one valley. That means you cannot have more than one valleys, so that will be a no for us. So they have said that we just need exactly one valley. If it is true, we just return an answer to be yes, otherwise we just say that it is a no. Fine. So all that we have to do is we just need to make sure that we are removing all the duplicates. That will just ease in the work for us, and we just check for all the values that we have. Now for all the values, what do we have? So what are we going to do? Remember, for this question, all we need to take care of is three cases. That means if we are at index 0, what do we need to check? We just need to check the right part, right? The right index. I'll just write it correctly right here. If we are at the 0th index, what do we need to do? If we are at the 0th index, all we need to take care of is the next index, that is a of I actually lesser than a of I plus 1. We just need to take care of this case. And if this is true, that means we actually have a valley that is starting at this index right here. Fine. This is true. Now, the next part is if we are at the n minus 1th index. That means we are at the last index. What do we need to take care of? We do not have anything to the right. We just have something to the left of me. So I'll be taking, or I'll be checking that if a of I minus 1 is greater than a of I. If this also exists, that means there is a value for me. But if not, if I'm somewhere in the middle, I know there will be a left to me and there will be someone to the right of me, right? So if for any particular I which is not 0 and the nth index, what do? We need to take care of all the cases. That is, we need to check the previous index as well as the next index. That means a of I minus 1 should be greater than a of I, and also a of I should be less than a of I plus 1. This is what we need to do. That's all. And if you just check all these conditions and you see, and you just count all the values, if these conditions are found to be true, just increment the values number by 1. And if we find more than one values at the end of the day, we just say that it is not possible and we'll just be returning a no, otherwise we'll just be returning a yes. Okay. And also, as I mentioned, you just have to remove the duplicates. Now why does removing duplicate actually help you? Let's just see. Now if we have something like this, let's just tweak this a little, and let's just say this is your correct array right now. Okay, so how will removing actually help us? If you see, there's this 2 and 2, right? Now if you see, this 2 and 2 are never actually forming a value right here. Even if you remove this, you see it doesn't actually hamper our test case right here, or our input statement right here. Even if it is forming a value, it will eventually form a value even if it is continuously repeating. If you have not understood it, I'll just repeat that again. Let's just say if you have something like this. See, if you have 5 ones in the middle, even though you have 5 ones in the middle, this does not take care of anything. Why so? Because all you have to do is just compare this, the starting index and the ending index of your subarray, with the next one and the previous one. So all of them in the middle do not actually matter, right? So actually we can just remove everything and we can just say, okay, I'll be just be keeping only one. Fine. After this is done, you can just simply compare it with the left one and the right one. If it does give you a value, increment your answer, otherwise just move ahead. Okay, so this is the whole algorithm, and I'll be sharing you the code as well. So this is the code. Okay, so the implementation right here is very simple. As I explained, all you have to do is just make sure you create a new array without any duplicate elements, duplicate continuous element, mind you. And after that, these are the base cases. If it is the length is 1 or the length is 2, it will always be yes. And for all the other cases, all you have to do is check for those three conditions. And for this, I'll be sharing the code link in the description as well. Please do check it out from there. It will be mentioned there, and you can always refer it from there. And yeah, this is it for this video. If you did enjoy this and if you did understand the solution, please like and subscribe.